So let's take a look at ASCII and Unicode. Once again, section 9.4.2, another death by PowerPoint presentation. So ASCII and Unicode are looking at how our ones and zeros go to represent different styles of text. We have to start with ASCII. ASCII stands for American, and that's the important word, American Standard Code for Information Interchange. It's the standard that is used to transmit text-based data between computer systems, or it was. And it's based on English, and that's why American is the important word. It's based on English, and this is the limitation. ASCII uses 7 data bits to represent English text. The 8th data bit is added for error checking. Go do the IPT syllabus for more information. Now, this means that all uppercase letters, lowercase letters, all numbers, all symbols on a standard keyboard can be represented in 7-bit ASCII. Languages other than English are nowhere near as lucky. Now, ASCII is not Chinese or Japanese. It can't represent pi or E with the circumflex across the top of it because they're not English characters. Simplified Chinese contains 8,000 characters. Traditional Chinese has about 50,000 apparently. Both go way beyond the scope of ASCII. The Greek alphabet, ironically, which gives the English word for the collection of letters, alpha and beta, an alphabet, are not English letters. ASCII cannot render them. ASCII can render 127 characters, 95 print characters and 33 non-print characters or control characters, which were used for communication. That's what ASCII does. So here's where, let's have a look at the ASCII table. Here is the ASCII table. It's actually really easy to read. Think about it as a grid position. You'll see across the top, in the top left-hand corner, it says bit position. We're reading the top row, 765, and then the left column, 4321. As you would in a spreadsheet. So reading the grid reference for your character is from most to least significant. The 7th data bit is the most significant. Now, there we go, 765, 4321. Easy. Let's take a look at, for example, capital G. We will read the top data bits, 765, 100, and then the left data bits, 0111. To work out the ASCII for capital G. So therefore 100, 0111 is our ASCII for the letter G. Notice also that every other character has a different grid reference. So pause the video for a moment, work out from this grid what is your name in ASCII. Bravely assumed you did that little exercise. Now here are the limitations of ASCII, and they're pretty big. 127 characters. The 128th character, 8 zeros, or 7 zeros, sorry, was never actually implemented. It doesn't deal with foreign characters at all, and so therefore ASCII has for the most part been superseded by this thing called Unicode. Unicode is a character set used to represent characters from all languages all around the world. The Unicode character set uses between 8 and 32 bits per character to make this work. And in fact, there are just over 1 million officially recognised Unicode characters, which is pretty much every character in every language. So we have 127 actually characters for English, 1.1 million for Unicode. Which one's more likely to be useful? Now, we use Unicode a lot. All modern computers now use Unicode as part of their file systems to allow for maximum inclusiveness, there's your word for the day, of users. That means that if I speak and write English badly, but if I was a native French speaker or a native German speaker or a native Chinese speaker, I could still read and write and save in that native language. Global companies like Facebook and Google cannot use the ASCII character set because they communicate in most languages around the world. So they have to have a character set to use for that. Equally, what's going on here? Windows now uses Unicode. Windows 9X, which is Windows 95, Windows 98, Windows Millennium, did not actually use Unicode. They were based on the FAT32 file system, which didn't use Unicode. It couldn't use Unicode. Whereas now, Windows XP, Windows 2000, XP, Vista 7, 8, 8.1, 10, all use the NTFS file system, which is Unicode. macOS uses HFS and APFS as their file systems. Doesn't matter what they are, it's the file systems that runs the operating system. They use Unicode. Unix and Unix-like operating systems use ext3 and ext4 as their file systems. They also support Unicode. So that's saying that pretty much every computer these days uses a Unicode-based operating system or Unicode-supported operating system. So we use Unicode a lot. Now, here is an example of the character map, pardon me, from Windows. And I have an Arabic letter, and you can see it's using a Unicode reference of U plus FBF1 down here at the bottom. And that means that it can be represented in Unicode. That is, again, a letter or a character that could not be represented in ASCII. This is something that you need to do with a Windows computer, and if you use the Alt key and the left Alt key and the Alt code that you want on the number pad, not the ones across the top row of your keyboard, it's got to be the number pad, you can get the symbol that you want.